Next up, we have Roxana. Hey, Roxana, how are you?
Hey guys, I am good. How are you doing?
Good. Thank you again we had a little bit of a flub with our agenda today, so thank you so much for staying up. I know it's late over there in England, so thank you again. And we'll definitely be sending you a bottle of wine. TJ's already on it, so we're
It's
good.
already worth it.
Nice. But Roxana comes from Almy, right? So she's the head of SEO over there. Actually, very interesting too. Roxana also used to work for GoDaddy. We had a lovely
Yes.
discussion about past histories about our stint over at GoDaddy. She was in the UK area version of it, and I was in the US version. And then, well, someone else took over, and we'll just leave it at that.
Yeah,
What a
pretty much.
fantastic talk about it, by the way. That was amazing. So why don't you go ahead and take it away? If you have any questions for Roxana, please put it in the ask a question area and she'll be able to answer it. After Roxana, we also have our keynote guy, Mr. Jim Boykin, who's also up and active on the chat area. So if you have any questions for Jim and you're thinking about it, he will answer anything and everything that you have. So Roxana, without further ado, please take it away.
Cool. Thank you. And hello, everyone. And thank you for joining me as I attempt to cover some potentially cool stuff around the htaccess file. And I've decided to do this talk not because I'm an expert by any means, and I'm not that great when it comes to servers, but because it took me years to put two and two together and realize how certain things are done and how they get implemented. So I kind of hope I can save you some time and help you come to the same conclusion I have, that the htaccess is a very powerful thing and that we shouldn't leave all this power solely in the hands of developers. And us as SEOs should at least understand the potential of the file and the benefits that lie hidden in this, configuration file. So, as Jim already said, I worked for GoDaddy a while back. In my career, I kind of started as a link building specialist. I did that for about 3 years. Then I joined WebFusion, which is a web hosting company. Got to work with a lot of big brands, and then as I was getting closer to my 10th anniversary in the company, I wanted to do something completely different. So I joined Alamy. And Alamy is a stock photography company. So it's funny because we were just talking about stock photos. Lily Ray, if you want to talk more about pornographic searches in the industry, I'm your girl. I know all about it. And Alamy actually has one of the biggest and largest diverse stock collection, which means it's really hard to just buy the same picture over and over again, because we have over 210 million unique images you can choose from. So, you can still use stock photography and not be duplicating images across the web. I've been lucky enough to be part of the beta for the image license feature that Google has recently launched at the end of August. And if you haven't heard about it yet, it's about these new badges that can be marked up to show on the images that are appearing in image search results that these images require a license to be used. So, these are really great for publishers, and it's part of Google's effort and continuous work on making users more aware of copyright laws, pretty much. So I've shared my experience around implementing these tags in a panel that you can access using the URL shown on the slide now, if you're interested to learn more. Right. I'm also part of the Women in Tech SEO group, a wonderful community for women in SEO in general, looking to up their skills or just share their knowledge. I also speak at various conferences, the most recent being Brighton SEO, where I did a talk on optimizing time to first byte. And if you manage to get your hands on a copy of Blue Array's Mastering In-House SEO book, you can find a chapter in there on speed, written by yours truly. So now we can finally get into it. The htaccess file is famous for helping us set redirects, but it can also help improve our website's loading times, as well as help with some crawling and indexing issues that I will cover in a bit. So I need to show you this disclaimer before we move on to anything, because this presentation is not meant to teach you how to modify your own htaccess file. In fact, I don't encourage anyone ever to modify their htaccess themselves if you're not 100% sure of what you're doing. And this is because this file deals with the configuration of your entire server and can easily take your whole website down. And if you think you know what you're doing, always, and I mean always, have a backup handy. So if anything goes wrong, you will be way faster to revert to a previous version of your htaccess than trying to debug what might have gone wrong in the first place. So with that covered, right, let's get into it. What is the htaccess file? And excuse my diagrams, but I usually try to visualize things to understand them. So let's imagine this is a server, and the way to add and store configuration rules on a server is by creating a text file that contains all the required directives. So an Apache server might look like the one in my diagram, where you can find a global configuration file called the httpd-conf, which can hold configurations that apply to all the directories on your server or can have directory-specific rules. Then in each of the directories, you can have another configuration file whose directives will apply to that directory and subdirectories only. And this is called the htaccess, and it is the subject of this presentation. So the big question is, why do we need both? Because both httpd-conf and htaccess, if the httpd-conf file can also dictate configuration for specific folders, which the htaccess does. So why do we need both? And it's pretty much because of how the httpd-conf file works. So for any modification in this file to take effect, you would need a daemon restart. And if you're not familiar with this term, imagine needing to restart your computer after Windows updates just to be able to use your computer again. So it can be annoying when you have to do it multiple times. With the htaccess, on the other hand, this file is read on every request. So any change will take effect with the next request coming in. This makes it easier to use for certain things, but really doesn't make it as efficient due to it always needing to be reread to check for changes. So to try and help visualize just how inefficient the htaccess can be, if we pretend this is our website structure with pages going as deep as 3 levels down, when a request is made to a page on level 3, Apache will try and read each htaccess file it finds along the way. Since we have one on every level, we can see from the log of system calls that Apache searches for htaccess everywhere, but only finds 3 along the way. So any rules from these files are then parsed and executed in sequence and can do anything from rewriting or redirecting URLs to setting arbitrary HTTP headers to even tweaking configuration settings for the Apache server itself. So if the htaccess file is so inefficient, why are we still using it? Why am I talking about it, right? So the problem is if you're on shared hosting, because you pretty much have no other choice than to use it. Because httpd-conf would affect the server globally, and you don't own that, you only own a portion of the server, your web host won't allow you to access it. So instead, you would only get access to an htaccess file in your hosting folder. So that's one reason. Another one's due to developers who tend to prefer using the httpd-conf only for things that are relatively static, and using the htaccess for things that They might want to edit easily and without restarting the Apache daemon every single time. So the recommendation, as found in the official Apache documentation, is to consider avoiding htaccess files entirely, and instead just to use the httpd-conf file to add all of your directives. But that's good advice when getting started with a fresh website. And most of us have inherited years of bad htaccess files through the websites we're working now on. So we need to do the best we can with what we have. And that being the case, let's try to get the basics right. Right, why do we call it htaccess? The name stands for hypertext access, and it's derived from the tool's original use, which was to control user access to certain files on a per directory basis, which pretty much still happens. It's also good to know that whatever rules you add in this file, they will be executed top to bottom, and that it's not written in a specific programming language like PHP or .NET or anything like that. It actually just follows a more similar construction to a robots.txt file. And by that I mean it works through directives and instructions. But unlike a robots.txt file, it allows you to use way more complex regular expressions. So your directives can be more advanced than just allowing or disallowing user agents and pages on your site like a robots.txt does. And if you haven't worked with regex in a while, it might be a problem. Because if you're not comfortable with regex, you might not get much out of your htaccess file. It uses a lot of regex to implement redirects because it tries to match them on patterns. So htaccess recognizes some predefined functions that are named modules or mods. When it comes to redirects, there are two such mods that are of interest. One is called alias and the other is rewrite. With the first one, it allows you to rename a file path by redirecting it to a new location. But it allows for some regex as well and pattern matching as seen in the second example by using the redirect match directive instead of the plain redirect one. But don't expect anything fancy to come out of this. For complicated pattern matching, we need to use the mod rewrite as this comes with extra options. And I think it's easier if we had a look at such a directive and see how it's built to make it easier to visualize it. It has four major parts: the rewrite rule, which is part of the mod rewrite syntax, the pattern section that is used for the rule to match on, the substitution part that we want to do when the pattern is matched, and flags, which are optional rules that we can add to any rewrite rule. And some of the more common flags include things like G for gone, which forces the server to return a 410 gone status, and for next, which will make the whole process of reading the htaccess file start again from the beginning. NC, which stands for no case, which makes the pattern not be case sensitive, so ignore any type of casing. And then we have the pairs QSA and QSD, which stand for query string append and query string discard. And these will cause the query string from the request to be appended to the end of the new URL in the substitution, or it will make sure that the query string is completely removed. And then we have the R flag, which will cause the rewrite rule to be processed as a redirect. And if it is not supplied, the URL will be mapped to the new location without redirecting. And if no value is specified for this flag, then the resulting redirect will be a 302, so a temporary one. And that's by default. And I think it explains why whenever we request redirects from our developers and we don't specify that we want them to be permanent, we end up with 302s because that's the default. So I think it's also noteworthy to remind everyone of back references in regex, as these get used a lot when it comes to redirects. So just to give a quick definition, a back reference in a regular expression that identifies, A back reference is a regular expression that identifies a previously matched group and looks for exactly the same text again. So when it comes to rewrite rules, whenever you see parentheses in the pattern or in one of the conditions, those parentheses can be used as back references in the substitution part of the rewrite rule. And to make this a bit simpler with an example, if we had a request for a URL that is test/1234, this would be transformed into that long and nasty looking URL you see there, because the green reference matches the word test, the red reference matches the number 1234, and then the purple one matches the host name. And then all of these references will be placed in their positions in the new URL as we desire them to be. So one of the most common issues I tend to see in old htaccess files are redirect chains. And even though redirects don't lose page rank anymore, and redirecting a page through multiple hops is not going to affect the PR juice, it does create a lot of other problems. They affect loading times. And with every hop that a page needs to go through to reach its final destination, it has to make a request. Every request needs to go through all the htaccess files present on the server down to the level where the requested page lies. So that means every htaccess file encountered along the way needs to be parsed and executed, and that happens on every single hop. So you might think it's something unnoticeable, and you might be right up to a point where it does become very noticeable. So this graph represents a test done to see how loading times are affected when more redirect steps are added. So of course, there are a lot of variables around the server's configuration, but it's still a good enough experiment for us to see that the server response time is somewhat not affected when one redirect takes place, but starts to go up for more than 2 redirects, and it is quite noticeable after 4. And that might be the reason why Google advises to reduce redirect chains and keep them ideally under 3 hops, but definitely not allow more than 5. And you can understand it from Google's point of view, right? Wasting their crawler's resources on following what might turn out to be a dead end is not practical. So it makes sense that the crawler would give up after going through some of the steps in a redirect chain. And if that happens, your end page might never get indexed. If it can only be discovered through the redirect chain itself, Google will never get there. But it's not just all about search engines now, is it? Users will perceive a delay in loading the end destination page if multiple redirect steps need to take place. So fixing redirect chains is actually quite easy to do. I usually start by copying all the redirect directives from an htaccess file. I paste them in Excel. There I break them into 2 columns, making sure I have the rewrite pattern in one column and the substitution in the other. I create URLs that match the pattern, and then by either using SEO tools for Excel, which is one of my favorite tools of all time, or using a tool like Screaming Frog, I try to get the HTTP status of those URLs. If those come back with just one redirect, I check if their destination matches the substitute column in my sheet, and if it does, all is well in the world. If it doesn't, that means there is another rule that happens before the one I am seeing, so I need to find out in which htaccess that might be if it's not in the one I'm looking at. If there's more than one step, then I need to simplify the redirect chain. So the way to do that is to identify all the rules that go into the chain's creation. As an example, if we have page A redirecting to B and B redirecting to C, it means there are 2 rules in the htaccess file. I have rule A redirecting to B, and I have another rule B redirecting to C. And if I update the rule where A redirects to B, so I skip the middleman and have it redirect to page C directly, that will fix the redirect chain. Now, htaccess is also quite commonly used to deal with duplicate content across a website. And as John Mueller said in a tweet a while back, even trailing slashes or the lack of them creates duplication across the web. And if you combine that with HTTP versus HTTPS, or using www or removing it from a URL, we can end up with 8 different versions of the same URL, and all 8 versions can return a 200 OK status. So even though this can be fixed by using canonical tags, you might want to use redirects instead to ensure your URLs always appear as canonical in the browser. It really helps a lot when people copy your link and they link to you from their website. You get a proper backlink. And the way to do that is by adding different rewrite conditions for different things. So I have an example here. When the website was created, the developer in charge added a redirect to always force www in the URL, which is great, but the end destination is on HTTP. Let's say 4 years ago, when Google said that HTTPS is increasingly more important and that we should all have secure websites, our newly hired developer bought an SSL, configured the server to use it, and then also added a new rule in the htaccess to push all requests to HTTPS. And then an SEO agency that worked for us said that shorter URLs are better and that we should always drop the trailing slash. So our developer added a rule that does just that. But when he added the rule, he left the destination as HTTP because he knew there's another rule somewhere that will make the URL HTTPS. So he just didn't bother. Now, I know I'm exaggerating, but I'm trying to make a point. So with the rules from before, requesting an HTTP URL that's missing www and has a trailing slash will first find the www rule, will execute that one, then it will run through your htaccess again. Now it will match on the HTTPS rule and rewrite the URL to use HTTPS. Then the newly formed URL will match on the trailing slash rule and execute that one. Because that rule wasn't updated to point to an HTTPS destination, the URL will again match the HTTPS rule and will finally become a URL that doesn't match anymore with anything in the htaccess, so it can finally be returned as a response. But that's a redirect chain that we don't need and could have avoided. Oh, sorry, here we go. So if you find yourself in a similar situation, the answer is to always update the redirect destinations of all your rewrite rules to always point to canonical URLs. So by doing this, you can also reduce the number of rules in your file. As an example here, HTTPS and www can actually happen in one go. You can play around with combining these to make sure you reduce all unnecessary redirect steps. So then, no matter if the requested URL is missing www or if it's on HTTP, it will always return the canonical URL as the final destination in one go, ideally. Right. htaccess files can also be used to rewrite URLs to make them more SEO friendly. We saw an example before where we can take different portions of the URL and rewrite them as parameters, but the reverse works as well, where you capture the parameters and by making use of back references, you use those values to create a friendlier looking URL slug. You can have a rewrite condition that removes the file extensions off of your URLs. So for example, your page doesn't have to end in .html or .aspx. Or you can make sure those /index.html or /main PHP pages will always redirect the above level, giving you cleaner URLs and getting rid of any duplication issues these can cause. Or maybe you're working on a website so old, you're still finding URLs written in different casing. And even though you can use any casing you want, you do need to be consistent, and that's hard if there's no casing pattern to follow. So it might just be ideal to lowercase everything. But do keep in mind that a redirect from uppercase to lowercase is still a redirect. So if you still want to do it, then it's quite easy to accomplish, but only if you have access to the httpd conf file, or at least have your web hosting provider make the changes for you. With this method, it allows for predefined substitution strings that can be used in a rewrite rule. This is called a rewrite map, and it cannot be used in directory sections or in htaccess files. So if you lack access to httpd-conf, there's another way you can do it, but it's not that good. With this method, it does only involve the htaccess file, but it also requires creating a rule for every letter of the alphabet, making it a not that elegant solution, but it is at least a solution. So hopefully you don't need to use it. So you can pretty much manipulate URLs however you like, and you can add redirects to any pattern you can create using regex, but we need to be aware that too many redirect rules can lead to performance issues, as it takes longer and longer for the htaccess to be parsed, and the time to first byte of your server's response time will be affected. This is probably one of the most well-known tests out there, courtesy of SEO Mike. He took an htaccess file and kept adding redirect directives to it and tested along the way to see the server response. In this case, the time to first byte starts going up after 20,000 redirects, and it doubles at 25,000, going from 100 to 200 milliseconds. It then jumps to 300 milliseconds at about 50,000 redirects, and it goes up dramatically after that as the file keeps increasing. But that is a very old test, so I wanted to see if the issue is still there with newer equipment. So then I found this more recent test from Simon Thompson, who took a simple text file and requested it multiple times, each time inflating the htaccess file that would have been needed to be parsed in order to get the text file. So we can see that the time to first byte starts slowly, going up after 10,000 lines of redirect directives. It doubles at about 50,000, and it keeps going up after that. So this test also suggests that having a large htaccess file in a folder can directly impact your time to first byte. And if you're thinking, yeah, but I don't have 50,000 redirects, who has those? You have to think again, because the effects are actually compounded when we consider that actual web pages don't have one request, they have a lot of them. And for each request individually, htaccess files have to be parsed every single time. So it is important to note it's not just a file size issue. It's more related to the contents of the file. So this is yet another test that tested adding 1 million redirect directives to one htaccess file and then commenting out the redirect directives in another htaccess file. So even though both files ended up having similar sizes, in terms of performance, the commented out file had a very small time to first byte, while the one with 1 million redirect directives that actually could be read needed over 4 seconds just to return a response. So in other words, the htaccess file size makes no difference. Rather, this is an issue of the server having to read all 1 million directives. If there aren't any to read, the server doesn't need to spend hardly any time at all parsing a file of the same size. So the lesson here is that just because we can use the htaccess to rewrite all of our URLs and redirect all of our pages, it is not wise to do it. There are situations when it would be difficult to create redirect rules that logically rewrite URLs with only one redirect. And sometimes we're better off just using our server-side languages like PHP or Python and create SEO-friendly URLs that way. And there are times when you'll need to combine your coding language with htaccess to achieve the desired result. So this is why it's important to understand what the htaccess file can assist you with if needed. But besides redirects, htaccess files can also be used to create a lot more other things. And one of them is custom error pages. I'm sure you've seen these annoying soft 404s that keep popping up in Search Console. And unfortunately, developers will sometimes create a redirect or return a page without the 404 status code when a product has been removed, a campaign is over, or just a page, needs killing off. And all of this can lead to these soft 404 piling up. So instead, you can make a helpful 404 page and make sure it serves a 404 status code so search engines can understand that it's safe to drop this content from the index. And once you've created a page that will function as the 404 template, then you can add the following code to your htaccess file to make sure the page also returns the appropriate 404 status code. And if you replace the 404 status code with any other code you want, you can serve and create custom pages for all of them. And all you need to do is just use a template that you want. So even for server errors, it's a better user experience if you're telling them that something went wrong and offer a few alternate pages they can visit instead of letting them see a dry message like this one for internal server errors. And the htaccess is just the most wonderful tool when it comes to page speed. For example, it allows you to set directives that control the browser and helps you leverage it. Most of the optimization tools like GTmetrix or Google Page Insights will recommend things such as leveraging browser caching, and that's because browser caching enabled websites tell web browsers to store resources like JavaScript, CSS, and images for a specified period, eliminating the need to re-download them on the next visit. And there are two basic ways to set browser caching. You can set a value for the cache control header, and this value should depend on how often you update your files. So for example, images never change their contents, so they can get a maximum time to be stored by the browser. PDFs might change more often. So based on that, you can add a more appropriate expiration time for the cache. The expires headers are another way of setting the cache time, but they're an older version, and in modern browsers, cache control will always take precedence. But if you still get visits from old browsers, it's good to add the same values to your expires headers as for the cache control, just to be safe. Enabling Keep Alive is another powerful htaccess trick to speed up your website. It enables the server and web browser to download resources on one single connection. This increases the page speed by not having to reopen the connection again and again. This already happens for the requests that are being served via HTTP2 on your server, but it's not happening for the ones still being served on HTTP 1.1. So nowadays, Keep Alive comes auto-enabled on most of the modern Apache servers, but you can also manually enable it on older ones if it's not done yet. And one of the best things you can do is to use compression. Deflate is a compression algorithm that is used to reduce the file size of files while they're still on the server. So when they're being sent back to the browser, they can be downloaded faster. Gzip uses Deflate at its core, but has different algorithm and other bells and whistles. But the question is which one is better, and you will find a lot of forums and people talking about this, recommending one or the other. I think the answer is it depends. And this is the point where you can talk to your developer and ask them to set up a test and see which one works better for your kind of files in your kind of situation. But either way, compression of any kind can help you reduce the file size for HTML, JavaScript, and CSS anywhere between 60 to 80%. Another htaccess trick is related to your site's images. Did you ever notice that someone is using your images on their website by using your image file link directly? If this is the case, every time someone visits that web page, images will be loaded from your server, and this is known as image hotlinking. So somebody showing your image on their website will be using your server resources and bandwidth, which leads towards higher load on your server if this happens quite a lot. And you can disable image hotlinking and speed up your website using a code similar to the one on this slide. In this particular case, you're saying that any request for the image that doesn't come from your website, your host name, or from Google, because maybe you are showing up in Google Images, as long as the request ends in any of the image files that you're expecting to see, like JPEG or GIF, instead of requesting the image itself, you can return a specific GIF of your choosing if you want to make fun of the person trying to hotlink to your image. Or you can return a page where you have a message about hotlinking, but these still consume your bandwidth. So the better option is just replace the last URL with a hyphen, and that will not load anything for them, not consuming resources on your server. The last speed-related trick I'm going to cover is the mod page speed module that Google has released especially for Apache servers. So I would assume that by now, most hosting providers support the mod page speed module by default. However, you can have it installed if needed by using SSH on your control panel. Once you enable it, you can use the htaccess file to configure it. And this module is genius. It can help you with stuff like minifying any type of file, optimizing file caching. It can help you combine external JavaScript files and optimize them. It can also help you optimize file loading by prioritizing important CSS and deferring JavaScript that you might not need. Optimize images by compressing them. You can convert images from PNG to JPEGs if you don't use transparency. You can resize images, and you can even convert them to newer image formats like WebP, for instance. So pretty good module. Have a look and see if it's configured for your website. Now, htaccess can also help with a couple of things when it comes to crawling and indexing directly. Did you guys know you can add canonical tags from your htaccess file? If you're wondering why you would do this, it really comes handy when you have non-HTML resources that we want to add canonicals to. So an example would be PDFs, since they don't have HTML, and the only way to add a canonical would be through the HTTP headers. And the only way to write the HTTP headers would be through the htaccess file. The same thing applies to images, but I need to warn you, from my experience, Google doesn't seem to be taking image canonical tags on images under consideration at all. I can't speak for other search engines, but I can confirm it for Google. Now, the xrobots tag also gets written using the htaccess and also becomes useful when dealing with non-HTML pages that we want to keep out of the index. Right, so if I haven't bored you to death yet, and you feel like learning more about the htaccess, then I wholeheartedly recommend you to go to Daniel Morell's website. He has a wonderful guide that covers everything you need to know about the htaccess file. And although he's a developer, the guide is done from an SEO point of view. It's wonderful. And then make sure to have a play with all these htaccess testers before making any changes to your file, or better yet, don't make any changes yourself. Just ask a developer to double check your work before you send it live. And that is all from me. I hope you found this presentation insightful, and I'm looking forward to some questions.
It was fantastic. Are you kidding me? We have a couple questions. Hopefully you'll be able to get to them. Let's see here. First one comes in from Craig asking, what's your take on why SiteGround's redirects are so slow along with time to first byte? Oh,
God. So because I worked in the hosting industry, I'm a bit biased. And I didn't work for SiteGround, so I'm, more than happy to trash them, but I don't think that's fair. A lot of these ready custom-made CMS solutions you can buy from different hosting providers don't seem to be the best when it comes to SEO elements, especially technical SEO. So I'm not going to trash on them specifically, but I'm just going to say if you want a proper website that you can optimize as much as you want, don't go with the out-of-the-box CMS.
Frank has a couple questions. The first one was, how different is IIS from Apache for the same work? I know, very different, but go for it.
Sorry, I was actually reading one of the comments, and I think I missed the essence of the question.
No problem. Yeah, so Frank was asking, what's the big difference doing all these redirects when you're using IIS versus Apache?
Yes, so it's a bit of a difference of syntax as well. There's even a difference of syntax between the htaccess and the httpd conf file, although both of them are on the same server. And I think this is why a lot of developers don't want to go through thousands of old lines of htaccess and have to transform that syntax to move it over. It's the same for Nginx. It's quite different from anything you would find in an htaccess when it comes to the syntax, although the idea of it is exactly the same.
I'm going to combine two questions. One's from Jim and one's from Frank. So Jim's asking if there's any automated tools to rewrite all the redirects. And Frank's asking, can you do this in regex to Canonical to replace thousands of them? So kind of similar approach, like bulk operations.
Yes, with the Canonical, because htaccess works with patterns. If you define a pattern for your Canonical, you can apply it on all pages that match that pattern without actually having to explicitly name a Canonical for every URL. So pattern matching is the best thing that htaccess does. When it comes to rewriting a lot of them, again, you wouldn't want to do one-to-one page redirects. You would want to find patterns and redirect all URLs that match that pattern. And that is better for you. It makes it faster to read the htaccess files. It makes it easier because you can always miss URLs when you do one-to-one. But if you want a tool that writes them for you, check out some of the tools I shared on my last slide, because you can kind of just put your URLs and the destinations, and then you get the regex for them. So you don't have to actually write it down.
And the last question actually comes from our next speaker, whom TJ can bring up on the screen here. It comes from Jim. He was asking, where can we get the book? Because it's sold out on Amazon for Mastering House SEO.
I know, it was a bestseller. It's not because of me. It had 25 other top SEO industry people in there sharing their experience, and that's why. So if it's not on Amazon, I'm really sorry. You just have to wait for it to become available again.
Well, this was fantastic. Thank you very much. We're glad that you stayed with us to do this.